All right. Continuing on in 5.4, we have the average value, or the average value of a function. But let's go. Here we go again. Here's another definition. The average value of a function. So the average value of an integrable function just means it's got to be continuous. Well, finitely discontinuous. Moving on. I have a function f on the interval a to b on the closed interval. It says the average value of this function that's in there, like just across this interval, is going to be, take the integral and divide by its length. And then divide by its length. Well, b minus a, the length. But let's go with something a little bit simpler. Let's just kind of start with this. Let's go back to average, the mean. So what happens if we had these numbers? 8, 10, 12, 6. And we want to find the average value of all of those numbers. We know how to do that, don't we? Add them up and divide by however many numbers there are. All right, wouldn't we just do one of these? Plus, and divide by 4. And then we get some sort of number. Oh, I don't know what it is. That's too much work. 18 plus 12, isn't that like 30? And then plus 6 is 36. And then you divide it by 4, and then that's 9. Yeah. Well, let's do it a little more fancy. Let's say we had some f of x sub 1. Uh-oh, here comes all the crazy subscript. And we had some... Oops, sorry about that. My stuff just started to get a little crazy. And then we had some f of x sub 2. And we had some f of x sub 3. And then it just kept going on and on. Let's add them all up. Let's do this same idea. And then we ended up with some f of x sub n. And now I got to go through and do something because I got to be fancy. I got to put little stars in here, little any points. Don't stress about that. Just let that go. Unless you're a math major, then we can have more talks. And then we're going to have to divide by however many there were. Like for this one, we had 4. For this one, we have n. All right. Yeah, crazy notation. Let's go. Oh, wow. Well, let's have a quick talk about this. Do you remember how we could write this top part? Do you remember this from Calc 1? That this is the sum from, which notation? They use k in this book. K equals 1 up to n of some f of x sub k. And I got to use the little star. Yeah. There's that function. There's the top. And then we want to divide by n. All right. Well, one more piece. Do you remember this? Do you remember Riemann sums, the delta x? Do you remember that? How wide is each rectangle that we're going to make underneath the curve? How wide is that rectangle going to be? Remember that this was b minus a over n? Do you remember that part? Well, let's solve for n. Well, n is actually just b minus a over delta x. That's just by moving the n over and dividing out the delta x. So let's replace this. Let's see what ends up happening. So we go through and we're like, well, this is the same thing as the function from k equals 1 up to n of some f of x sub k star, of course, divided by this b minus a over n. Or n. Come on, man. Be better than that. Delta x. But look what ends up happening. You know when you divide by a fraction, that thing just flips up to the top? So we're going to end up with k equals 1 up to n of f of x sub k star, to be fancy. Well, that delta x is actually just going to pop up to the top, and we're going to divide by b minus a. And the way we could write this is 1 over b minus a times the sum of k equals 1 up to n f of x sub k star delta x. Well, that would be just for finitely many little rectangles we're making. Just taking you back to Riemann sums. We got to know that stuff. That's prior class. So why don't we get it to the integral? Let's make infinitely many. So let's take the limit as n goes to infinity of the sum from k equals 1 up to n of f of x sub k star delta x. We must know this. We must know this. We must know this. That is the integral upon the interval for which we're going for. So this interval is from a minus b. Therefore, this is equal to 1 over b minus a times the integral from a to b of f of x dx. And this is equal to our average value of the function. Look at all that. Look at all that. Did you follow any of that? If not, you're okay. Don't stress. Don't stress. This is not a proofwriting class. You are responsible for the outcome. But you're also responsible for being able to recognize when this application is, well, applicable. So let us check out and see if we can't do an average value of a function problem. So let's set one up. Okay. So let's find the average value of the function, where our function is, let's make it this. And then we gotta have an interval. We don't have an interval. Now how the hell are we supposed to know what the average value is? From -1 to 1. Let's keep them nice and simple. Nice and simple. Let's not get crazy. So we know that this is equal to 1 over b minus a times the integral from a to b of our function, we'll call that f of x, dx. So let's set it up. Here's our a, here's our b, there's our frickin' function. So we're going to say the average value is equal to 1 over, and our b is, oops, sorry about that, is 1, and then we need to subtract out our a, which is -1. Cool. Then we're going to integrate from -1 on up to 1 of our function, or 1 plus x squared dx. So let's clean up that left-hand side here. Let's say that's 1 over, so 1 plus 1, that's 2. We're going to take 1/2 the integral from -1 to 1 of 1 over 1 plus x squared dx. And of course, we all recognize 1 over 1 plus x squared, right? If not, trust me, you will. You will. That's the derivative of inverse tangent. Meaning, when you take an antiderivative on this, it's just inverse tangent from -1 to 1. Now this time I left my line, my straight line on the right hand side, saying the antiderivative has already been taken on the outside of the parenthesis. It could be on the inside. It doesn't really make any difference. I don't even really need to put any parentheses in, period. I want you to see it. So now we can say that this is 1/2 of. So it's inverse tangent and inverse tangent. And then we just pop in our bounds, 1 and -1. I think inverse tangent is an odd function. We could cheat it here if we wanted to. You know what I mean? So inverse tangent of 1 is clearly pi over 4. And then we're going to subtract out the answer from inverse tangent of -1. And again, it's an odd function, so it's -pi over 4. So we put them together and you have 1/2. So if I have 1/4 of a pi and you give me another 1/4 of a pi, I think I have 1/2 of a pi. Multiply it in and we're like, bang. The average value of this function, 1 over 1 plus x squared from -1 to 1, is pi over 4? Wow. There it is. That's the average value of a function. So, of course, there's going to be much more challenging problems, but these are not designed to give you the tough problems quite yet. We just want to make certain that we kind of know what the heck is going on. So, cool. There's some average values of functions. Neat. I'll see you in the next.